Today we are going to put together some different pieces that we've been learning about solving equations and working with expressions. And we're going to combine a bunch of different pieces and we are going to work on solving some multi-step equations today. So these are equations that we have been kind of working up to. Now if you're thinking, wait a minute, we were just doing inequalities yesterday and now we're back to equations. This piece is going to connect with an inequality piece tomorrow. So that's why we're kind of going back and forth between equations and inequalities. So we are putting some pieces together and then we're going to roll it in with what we've been working with the last couple of days with working with inequalities. So what you have in your notes outline that we're going to use as an example, and we're going to talk about a couple of other ones as well, is a multi-step equation. So right now this is kind of a long looking equation. We're going to talk about a step-by-step process that you can go through to solve any equation that looks like this. So we're going to put our example on one side with our work all nicely organized so you have a model of what your work should look like, and then next to it we're going to put the steps so you have a reminder of what order to do things in. So here we go. When we talked about simplifying, we said that whenever you have parentheses, the very first thing you should do is get rid of the parentheses using distributive property. So when we have an equation with parentheses, our first step is that exact same first step as when we're simplifying. So that is going to be our step one. So use distributive property to rewrite parentheses. I'm going to abbreviate parentheses. This problem has parentheses in two different places. Once on the beginning and then again at the end. So we need to rewrite both of those. So let's go through and rewrite both of those. So this first step wants us to multiply everything by 8. And I'm actually going to do, before I do this, I'm going to do an intermediate step that is one that I've been encouraging you guys to do, and that's to go through and change all of your subtraction to adding before you try and work with your equation, because that's going to help you to keep track of the negatives in the problem. So before we do that, first use distributive property step. I'm actually going to go through and do that really quickly. So 4x minus 1 turns into 4x plus negative 1. Minus 12x is plus negative 12x. And then 2x minus 6 is going to be 2x plus negative 6. So kind of quickly going through and changing it into addition, and now we can see where all of our negatives are. So now we're going to go through and we're going to deal with those parentheses. So we're going to do some distributive properties. So this first one wants us to multiply everything in the parentheses by 8. So we're going to do that. So 8 times 4x is 32x plus 8 times negative 1 is negative 8. And then we've got this negative 12x just kind of hanging out there. It's not in the parentheses, so it's just going to kind of hang out at the end. So I'm just going to rewrite that just so we remember that it's there. And now we've got another set of parentheses. So the next set of parentheses wants us to multiply everything by 11. So now we have to go through and multiply everything by 11. So 11 times 2x is 22x. And then plus 11 times negative 6 is negative 66. So that's our first step. So our second step is going to be to simplify each side. So the thing you have to remember, and I'm even going to go through and kind of draw a line here. So this equal sign is kind of like a wall. So we can't just stick things together that are on opposite sides of the wall. So that's why when we say simplify each side, we have two separate expressions. We have a left expression and a right expression. So we have to simplify those expressions one at a time. So simplify each side. So we'll start on the left. So on the left, I see two different problems where we've got some, goodness, this just not want to stay still. Where we've got x's, so those are like terms because they both have an x, so we can put those together. So 32 and negative 12, that's going to give me 20. So I can put that together, make that a 20x. And then the negative 8 doesn't have anything that goes with it, so it's just going to hang out, still be a negative 8. And then the other side, I'm just going to rewrite just so I can keep things going straight across in my equation and not have things go lopsided on me. You don't want your equations and your work to go lopsided, because if your work goes lopsided, it's going to get hard to keep track. So if you need to, just rewrite something, so that's actually what I'm going to do right now, just to keep things lined up straight across so it's easy to see which things go with which other things, then you can go ahead and do that. So now this has turned into a variables on both sides equation, which is a type of equation that we've talked about. So that's the next thing that we're going to do. And we said that when you have variables on both sides, we need to look and see which one's smaller. So if we have a 20x and a 22x, and we should cancel the smaller one. So that's going to be the 20x. So cancel. Think of a good way to put that. Cancel smaller term if variables on both sides. So it's really your variables on both sides steps. And you have an entire lesson worth of notes on that, because we did a whole lesson just on this type of equation. So if you need to look back at those notes to kind of remember and have some more examples to look at, then that is something you can absolutely do. So when we did it, we said, look at both of them and cancel the one that's smaller. We usually try and get rid of the smaller one because it helps most of the time keep us out of the negatives. So that's the 20. So that 20x is positive. So a way I'm going to cancel that is with a negative. We also know from what we've been learning with equations that whatever I do to one side, I have to do to the other side. So I need to show that I'm doing it on both sides. So on this side, those are going to wipe each other out. And all that's left is just this negative 8. On the other side, 22x minus 20x is 2x plus negative 66. And again, notice that I'm keeping everything lined up straight across so that my work is nice and easy to track. So now that's a two-step equation. So we can go through our steps and just solve the two-step equation. And we've seen, I'm going to abbreviate equation, EQ. We've seen quite a few two-step equations at this point. So we're going to zip through the last little part of this and finish this off really quickly. So we need to get rid of the negative 66 first. So a positive cancels a negative, so plus 66. Those are going to cancel each other out. And then on the other side, we have negative 8 and 66. So those are going to make 58. And notice that every time I do something, I'm rewriting. So when I subtracted, I rewrote before I did the next step. And then when I added, now I'm rewriting before I do the next step. So every time you do a step, you should rewrite the equation. First of all, it's going to make your work easy to follow if somebody else is trying to look at your work. Second of all, it's going to help you to not lose your place, because if you've done 4 different things but you haven't written them down, it's really hard to remember in your head what you've done, and that can cause you to potentially make a mistake. So always rewrite the equation after you do each step so that you can see what your equation looks like and see what you need to do next. So this is now a one-step equation. We just have to undo this multiplying. So 2 times x we would undo by dividing. (58) divided by 2 is 29. So that is our answer. And that gives you the steps. So use the shiverative property. Use what we've learned about simplifying to simplify each side. Use what we learned about variables on both sides. And then use what you've learned about two-step equations. So that's why I said this is a whole bunch of putting different things together that we have talked about so far. Now we are going to look at a couple more equations. So these are solving equations special cases. So special cases are basically kind of unique things that can happen when you're solving an equation. And now that we're working with some longer equations, we need to talk about these special cases because sometimes these things happen, and if they happen, you need to know what to do with them. So we are going to zip through, and I'm going to zip through a little quicker because you already have the steps all mapped out up here that you can look at, but I'm going to quickly zip through these steps to get us closer to the end of these equations because some interesting things happen at the end of these last two equations in your notes that we need to talk about. So let's zip through our steps. So first step is distributive property. So if we do distributive property, I'm just going to rewrite the left side because we're not doing anything with it, but I want to keep everything lined up. So 3 times 2y is 6y. 3 times 4 is 12. And I'm going to go ahead and change my subtracting into adding while I'm at it early in the problem, plus -8. So I've got like terms I can combine, so that's my simplify step. So 7y plus -8. So the 6y and the y I can put together and make that, ooh, that went flying, into a 7y. Now we're on our variables on both sides step, and this is where we get into a little bit of an interesting situation. So I said these are special cases. So these are basically unique things that can happen sometimes when you're solving an equation. So normally, if we have variables on both sides, we would look at both of them and we would decide which one's smaller. Well, in this case, they're both the same. If they're both the same, it doesn't matter which one I get rid of. I can get rid of the 7y or I can get rid of the 7y. It doesn't matter. So the way I would get rid of a 7y is by subtracting it. So I'm going to go ahead and do that on both sides, and that's kind of checking off that variables on both sides step. So what's going to happen that's interesting is because this was the same on both sides, when I cancel it out, it's going to cancel it out on both sides. And I get left with this. Now, this is where things get a little interesting because the y's just went away. I can't figure out what y equals if there are no y's left in the equation. What I'm left with is this very weird statement, -8 equals -12. So hopefully you're looking at that and already thinking, but -8 doesn't equal -12. They're not the same. So that is what we call a false statement in math. And we talked a little bit about false statements with inequalities. So this is another example of a false statement. So if you're solving an equation and you're going along in your variables, pull a vanishing act, and you are left with a numbers only false statement. What that's telling you is that these two expressions, so this expression and this expression, they're not actually equal. That's what that's telling you. So if they're not equal, then there's no number for y that is going to magically make two things that are not equal all of a sudden be equal. So that means what this is telling you, or what it's trying to tell you, is, hey, these expressions aren't actually equal. This equation is not actually an equation. It's broken. So your final answer, if this happened, would be that there is no answer. So what you would write down, oops, I forgot to turn my highlighter off. What you would write down as your final answer is no solution. Now, if this happens to you, you do need to have that written down on your paper to show that you understand that this false statement means there is no answer to the equation. So that's why I literally boxed it, because that is your answer that you should have written on your page. So if you just stop at -8 equals 12 and don't give me anything else, I will not give you full credit, because you have not shown me that you understand what that means when you get an answer like -8 equals 12. So you need to take that last step and say, okay, that means no solution, and actually write no solution on your page. So it is possible to have an equation with no solution if you get this false statement. And what that means is that we took two things and tried to say they're equal when really they're not actually equal. So we can't make an equation with things that are not actually equal. So let's look at this last one. So your last example is right here. Again, let's zip through our steps really quickly and see what happens. So first we need to use distributive property. And this one, actually, before I even do that, I am going to change my subtraction to addition. So minus 2, we're going to turn into plus negative 2. Just so we don't lose track of our negatives. Now we're going to do some distributive property. So 3 times 4x is 12x. 3 times negative 2 is negative 6. Plus 15. I'm just rewriting the other side just to keep things lined up. I can put those together, so our next step is simplify. So negative 6 plus 15 is 9. Now, I want you to stop and look at what we just ended up with before we move on to our next step. 12x plus 9 equals 12x plus 9. Hopefully you're noticing that the left side and the right side are exactly the same. These two expressions are what we call equivalent expressions, which basically means the expression is mirroring itself. So this is going to be very interesting as far as answers go, because since the expression is itself, it's the exact same expression on the other side, I can put any number I want in for x, and it's going to give me the same answer because I'm filling it into the exact same thing on the other side. So if you stop and think about that for a minute, logically that makes sense. If I fill a number in and get an answer, and I fill a number into the exact same thing again, of course I'm going to get the exact same answer. So I can fill in any number I want. I could fill in a 0. 12 times 0 plus 9 equals 0. I'm going to get 0 on the other side too. I could fill in a 1. 12 times 1 is 12, plus 9 is 21. If I fill in a 1 over here, I'm going to get 21 on that side too. So these two sides are always going to equal each other no matter what number I fill in, because the expression is mirroring itself. So if you really wanted to keep going with your steps, so you could, really kind of stop there. If you realize, wait a minute, this is mirroring itself. Mirrors itself. If you really wanted to keep going through your solving equation steps, your next step would be to deal with your variables on both sides. Since both sides have a 12x, our only choice is to get rid of a 12x. And you're just left with the 9s on both sides. This is a little different than the last problem. The last problem we got negative 8 equals 12, and negative 8 doesn't equal 12. This problem we're getting 9 equals 9. Well, that's a true statement. So if you get to this point where your expression is mirroring itself, then you could actually stop on this one, and your answer would be what we call infinite solutions, which basically means I can pick any number I want, and it's always going to work. Because when I fill the number in, I'm just filling it into the exact same equation or expression, which is going to give me the exact same answer on the other side. So no matter what I fill in, the two sides will always be equal. So that's what infinite solutions means. Basically, there is an infinite amount of numbers that will make this work. I can fill in any number I want, and it will always work. Now, if you are plodding along through your steps and you don't catch that spot where the expression's mirroring itself, and you get all the way down here, then your other kind of giveaway for infinite solutions is that true statement. So if you have infinite solutions and you go all the way through your steps, you're always going to end up with your variables gone, but you'll have a true statement. So 9 always equals 9, which basically means this always works. You can fill in anything. So there are two special cases. So normally, like up here, this first example, x equals 29, we'll go through the equation and we'll just have one answer, one number that makes it work. But sometimes we might have two things that aren't actually equal and have no solution, or we might have something that's mirroring itself, which means we have infinite solutions. So when you're solving an equation, you need to kind of be on the watch for that no solution and that infinite solution situation, because sometimes that might happen to you when you're working with an equation. So you should have all three of your equations and your notes worked out at this point. You should also have your steps written in for that first example so that you have a reminder of what order you should be tackling these problems in. So when your notes are complete, then